Ladies and gentlemen, welcome to trèSci Weekly, episode 5. I'm one of your hosts, Jonathan Ullman. Alongside, he's living La Vida Loca, Tom Kaya.
Came out in 1999, that song.
1999. God bless.
And I've been living the Loca ever since.
Ricky Martin.
Exactly. Martin, I think, yeah.
Yeah. What's going on, dude?
I'm doing well.
Yeah.
Feeling good.
Cool.
I was just telling you before how I saw the movie Logan, and I'm still thinking about it.
Yeah, right on.
It's an amazing movie.
Sweet. Gonna have to check that out.
Yeah, I'd recommend it to anybody.
Hell yeah.
Best X-Men movie I've seen.
I do love the X-Men.
I feel like you gotta.
Yeah. What else?
How are you?
I'm doing well. Busy week this week. Swamped with work.
Swamped.
Yeah. It was kind of photo finish getting all this stuff for the show together, but that's cool. Had Kayla's mom's surprise birthday party yesterday. That was nice.
She looks good for her age, by the way.
She does.
Not trying to hit on her mom or anything, but I saw the picture. She looks nice.
She does look nice. No. So yeah, shout out to Karen Riley. Happy birthday.
Happy birthday.
Again. Yeah, thank you guys for joining us. This is trèSci Weekly. This is our weekly show where Tom and I will bring to you all the science news for the week, and we'll kind of discuss our thoughts and feelings on it.
Well, not all the news, but
Well,
all
the news that I care about, really.
Yeah. We're not going to tell you about lame stuff.
No, just the good stuff.
Yeah.
This is going to be a good show. A lot of diverse. Last week was all about space news.
Yeah,
this
we
week,
have a few more different topics.
Yeah, very diverse set of stories to choose from here. We did not get together on Saturday.
Oh yeah, to discuss planet Earth.
Yeah, we didn't do that.
Complications.
Some complications scheduling wise. Did you watch it?
I actually did not yet. I have a DVR'd though. Was it a good one?
Oh, you gotta check it out, dude. It was awesome.
Man.
It was awesome.
What was the theme? Was it
Jungles
this
week?
Nice.
It was cool. Yeah, I don't want to spoil anything for you, but
okay.
Yeah, it was great.
Sweet.
Let's see. Anything else? You said you wanted to say something about.
Oh yeah. So we saw a story. I think we saw it on Facebook about an octopus that escaped from an aquarium. I actually don't know which aquarium it was from, but he managed to escape and get all the way to the ocean, which is part of the plot of Finding Dory, where Hank the octopus is smart enough to escape and get all the way to the ocean, and this guy did it.
Nice.
Maybe he was inspired. I don't know if he even saw the movie, but he did it.
It's possible. Yeah, you were saying that octopus, very crafty little buggers. I agree with that.
Yeah. Cephalopods, they're all very smart.
They are.
Yeah, my girlfriend Christy wanted me to bring that up. She's like, it's just like Hank, the guy in the movie.
I didn't see Finding Dory.
Oh, okay.
I wanted to. I was super hyped.
Nowhere near as good as the first one, but
really,
yeah.
Bummer. I like Ellen's parents.
It's kind of like the same storyline, so it was kind of like blah. But
okay. Before we get into the news, let's just go through the spiel really quick. This is trèSci Weekly. You can join us every Monday night at 8:30 live to chat with us in our chat about the science news that we talk about, and we encourage you guys to do that because it's a lot of fun. Last week we had 10 people with us. That was exciting. We decided that this week, if we have some people that are hanging out in the chat, we'll spend some time with you guys. If you have questions or comments or concerns or anything, we'll just take a few minutes at the end of this show to chat with you guys because we love you.
Yeah. We'll have a quick little 5-minute chat session.
Sweet. You can always catch the show for free after the live recording of it on our YouTube channel. Our YouTube channel is still a horrible URL to read off. I don't have the URL, so I'm not going to try to read it off. But we're up to 19 subscribers.
How many subscribers do you need?
A hundo.
You need 100?
Straight hundo.
To get a cool link?
To get a cool URL.
All right.
So we're getting there. We'll get there. Otherwise, you can like us on Facebook, facebook.com/trèSci Weekly. You can follow us on Twitter at twitter.com/trèSci Weekly. You can support us financially at patreon.com/trèSci Weekly if you felt so inclined. You don't have to do that, of course. And yeah, you can always email us at trèScimail@gmail.com.
Yes, you
as
can.
well. Tom, let's begin with the first story this week.
What's our top story?
So I'm just joking. I didn't order them in importance.
Order, right?
Yeah, last week I kind of did order them in importance. This week I kind of just went chronologically because it was a busy week. First story is about fish. Surprisingly, Ryan Nash did not tag us in this story.
The fish man.
The fish master himself. We should do a podcast with Ryan Nash where I introduce him as the fish master. That would be fun. All right, number 1. Have humans become seafood snobs?
I don't know if I really like that first sentence.
You don't like it?
It kind of turns me off to the whole, but I like it though.
Okay.
Like it. Have we?
I don't know. I'm asking you.
I think we have. Question.
Okay. A recent study by Tim Cashin and colleagues suggests that this might be the case, and that it is detrimental to sustaining food security, especially in developing parts of the world. The researchers looked at trends in fish used for direct human consumption versus fish used for fish meal/fish oil production, aka fish used to feed other fish or livestock, from 1950 to 2010.
So we're looking at fish that we use to feed other animals or make fish products versus fish people would just consume directly.
Correct.
Okay.
Correct.
So what do we find?
So they found that, quote, over 90% of fish landings destined for fish meal, fish oil, or other non-direct human consumption uses are food-grade or prime food-grade fish, end quote. So what they're saying is that most of these fish, 90% of these fish that we don't eat directly, we could eat directly.
Yeah.
They're great. Their quality
is
is food grade, right? According to the study, the top 5 fish species used for fish meal production are the Peruvian anchovy, the Pacific sardine, the Chilean jack mackerel, capelin, and the Atlantic herring. Even though humans could eat these fish, market demands from developed countries for higher quality fish such as tuna, trout, and salmon mean local catches are likely to be sold to fish meal plants rather than to people for consumption.
So that's a pretty big problem. If you're in a developing part of the world, we're taking fish that they could just directly eat to live on, and they're taking those fish, sending them to other places, fisheries who are paying more money for them to feed other fish and animals or make products out of them.
Yep.
Which is, I don't know, that's kind of disconcerting a little bit.
Yeah, certainly is. The problem is self-perpetuating and ocean fish sources are finite. Quote, from a purely energetic perspective, using fish as feed is inherently less efficient than feeding fish to people. Furthermore, the high-value aquaculture species such as salmon and trout are net consumers of fish protein and thereby reduce fish availability, right? So that makes sense, right? So we have fish for fish meal are being fed to fish that we eat,
yeah.
And then we eat them. We could cut out that middle step there and just eat these fish, right? Instead. And furthermore, the fish that eat the fish meal, like, they're eating more than one fish, you know.
Yeah,
like
so
we have to raise
keep them
fish.
Alive, we're actually losing animals and livestock. A lot of it.
A lot of it.
But you know, the way to make money is usually not the most efficient way. So this is another example of that case.
Exactly. These fish inputs are often sourced in waters of developing countries, putting pressure on their fish populations, as well as reducing access to fresh fish for local human consumption. The final aquaculture products are often, but not exclusively, exported to developed countries and are thus an export of animal protein and micronutrients from many food-insecure regions, end quote. So, not only are we taking the fish out of their local habitats, we're taking them in areas of the world that could really use the fish. Yeah. So that's not a good plan. On a positive note, the researchers indicate that certain species such as capelin and Atlantic herring have been recently trending away from animal consumption and back to human consumption, right? And the image credit for this particular story that we have goes to Andina, which is a Peruvian magazine town.
Oh, wow.
Yes.
I did not know that.
Yes, it is. So that's good news, right? So they've noticed that this is happening.
That this is a problem.
They're trying to turn it around. They're trying to get some of these fish meal fish back on the menu, if you will.
Market, yeah, getting people buying those fish again.
And they've been pretty successful doing it. But we have to do it.
Right? All the way, yeah.
We have to make an effort.
Make the full change to actually make it happen.
Yeah. How do you feel about this? You're not a seafood guy, right?
No, I don't eat fish at all.
Wow.
I take omega fish oil pills.
Okay.
Because I used to have a high fat diet because when I worked out I ate a lot. So I would need omega-3 to counteract my triglycerides because I didn't eat fish.
Gotcha.
So I would take fish pill supplements, which is also made from fish meal stuff as well.
Yeah.
But it's kind of an important part of your diet. So I think people need fish, and whether they get it from a pill or eat it directly, I think, everybody should have it in their diet.
Yeah, I agree. My diet, I used to eat like trash all the time. I think you'll agree with me there. You've known me a long time.
Yeah, it's back in the day.
We used to go on fast food dates together, you and me. I have since changed my diet quite extremely. About a year ago now, actually. Yeah. I gave up red meat and poultry, but I still eat fish.
That's your main.
That's my main source of protein. Yeah. And it's.
But a lot of the fish out there, it's like cod and other things that currently they would be feeding this fish meal too, right?
Yeah. So
that's kind of like the main market here.
Yeah. So, I wouldn't be opposed to eating the food grade part of anchovies or sardines as long as it's like,
as long as it's pretty good.
Yeah, it's prepared, right? Good condition, right?
Yeah.
I just feel like I don't ever have the option. I don't see these fish anywhere. Grocery stores, menus on restaurants, Blue Apron. Nobody does that stuff. So
there needs to be like a big shift, I guess.
Yeah. How do you solve the problem here? I don't know. Could stop eating fish. Stop eating the fish that I eat, salmon, tuna, shrimp. But then it's like, eventually I'm not going to have any food left to eat. So I don't know what to do about this.
Yeah, I think it's just a problem with like the distributing of the food. Like, they're making money on these fish, and they've been doing it this way for a while, and we can tell it's not a good way. It just is the way it is.
Mm-hmm. Yeah. Well, kudos to these guys for bringing attention to it. Hopefully we'll figure out a new way.
Yeah, Kayla said there's only so many fish in the sea.
That's true.
They always say there's a lot of fish in the sea, but I mean, what if you get rid of all the fish?
Yeah.
Then we can't even have that cool phrase anymore. We don't want that.
Seriously.
All right, moving on.
Number 2, some space news.
Nice.
Because we always got to have space news. A supermassive black hole observed in a galaxy about 1.8 billion light years away is presumed to have spent the past 10 years devouring a star that's wandered too close. This is an unusually long time, as most observations of these events typically only last about a year or less.
So this is, just to get everybody on the same page, this is kind of what black holes do, right? They suck in things. They don't suck.
Careful.
Right? They don't suck.
I corrected a student on this today, actually. Black holes do not suck. They're not a pressure system. They are a gravity system. So you fall into a black hole. You do not get sucked in by a black hole. But for all intents and purposes,
it's just everybody uses that vocabulary.
I know.
Just like
I use it today too. Because you fall in pretty rapidly because the gravity is pretty strong at a black hole.
Yeah, I think people use like the analogy of like sucking something up in a vacuum, like even like one you use around your house.
Yeah.
Like, kind of just takes it in quickly,
Yeah.
There's not a lot of good vocabulary words to describe that.
It's a pet peeve of mine. I actually corrected NASA on a tweet one time.
I remember
about
you did,
that. Yeah. Stickler. But
this is what happens. Yeah, when you get too close to the event horizon, there's nowhere to go. There's so much gravity. You're going in the black hole, right?
That's true. We should make it a point to say too that a black hole is not a hole; it's a star. It has a surface. It's just the gravity and the mass is so large that the light does not escape the surface.
The way I like to explain a black hole is if you think you're on a flat plane of space-time, as you get to the black hole, there's the event horizon where at that point no light can get out of it from anymore, right? So that's why they call it black, because you can't see anything.
Right.
And then I like to picture of it like they show it sometimes like a funnel, and then there's the singularity, the really dense star that is actually the center of the black hole.
Yeah,
right?
Yeah. Because volume goes to zero in a sense, so your mass over
so
volume.
Much mass. Yeah, it's almost like infinite density, almost.
Infinite.
And that's what makes the black hole.
Exactly.
Okay.
So
we just have to get that.
No, yeah, it's just fundamentals for everybody who doesn't know. Here we go. Okay, astronomers detected a signature X-ray flare by chance when observing another foreground galaxy back in 2005. Right, so their field of view.
So usually when you see a black hole, there's X-rays that get emitted from it.
When this happens, right?
When something's being accreted into it.
Exactly. So field of view, they're looking at some galaxy. Behind what they're looking at, they notice a spike in X-ray emissions, and they're like, we should check that out. Probably.
Yeah, let's see what that is.
The X-ray source, you ready for this?
Yeah.
Named 3XMMJ1500052.0 plus 015452. Rolls right off the tongue.
That's the X-ray source? Okay.
That's the name of it. Became the focus of subsequent studies conducted by dedicated telescopes such as the Chandra X-ray Observatory. According to the study by Deshang Lin and colleagues, quote, one striking property of the source is the fast rise, very slow decay outburst profile. It was not detected in the first Chandra observation on April 2nd, 2005, with luminosity less than 4.3 times 10 to the 41 ergs per second. Less than 4 months later, July 23rd, 2005, the source was detected in the first XMM Newton observation with luminosity about 5.5 times 10 to the 42 erg per second. It was detected at an even higher luminosity 3 years later in one Chandra observation on June 5th, 2008, and 2 XMM Newton observations in February 2009 with luminosities around 7 times 10 to the 43 ergs per second. Luminosity decreased only slightly to around 3 times 10 to the 43 ergs per second in 7 Chandra observations in March to April 2011. Similar luminosities were seen in our follow-up observations later, one by Swift on March 28, 2014, one by Chandra on February 23, 2015, and 7 by Swift in February 2016, right?
So if we go all the way back, it started in 2005.
Yep.
And what all these luminosities are is saying that we are observing something that is a star, basically, right next to this black hole.
So this is the X-ray luminosity, right? This is all part of the same event, right? We can't really call it any one particular object, I guess, because we can't really resolve what it is. We just see the X-ray source coming towards us.
So we don't know for sure if it's just like one star being accreted in?
No, we don't.
Okay.
With mathematical models, they are pretty confident that that's got to be what it is because they've kind of seen this happen before.
Yeah.
But I mean, remember, we're looking 1.8 billion light years away. That's hard to look that far away. And so these X-ray sources are extremely bright. These luminosities are insane. Yeah. So what I was referring to as XMM Newton, Chandra, and Swift, those were all telescopes that they're referring to, looking at these events, or this particular event. And yeah, so basically they see a spike in the brightness, and then the brightness stays pretty steady, right? They describe it as fast rise, very slow decay, right? So if you're looking at a graph, right, fast rise, very slow decay. And that's unusual for this type of event. Usually it's fast rise and then a pretty rapid decay, right? It falls off pretty quickly. So the researchers propose the unusually long event may be because the star being torn apart and swallowed up by the black hole is very massive, around 10 times the mass of the sun. Or the alternative could be a star with just double the mass of the sun that happens to have a slow circularization process as the star's matter forms an accretion disk around the black hole.
All right. So
we have a video.
There are two theories of why. Okay.
Yeah.
I just want to go through it real quick.
Sure.
There are two theories why they're seeing it for so long. Is that it's a big star that's going into the black hole, or that it's taking it a while to sort of begin this accretion process as it's pulling it in.
Right.
Okay.
So typically, like, people think about a black hole swallowing a star, they think the whole star just gets swallowed up. But really, what happens is the star also has
closest
mass
to it. Yeah, is like it very slowly trails and begins to go into it.
Right, because
it doesn't just all pop in at once.
Yeah, the surface of a star is a plasma. It's a gas, and so the mass of the black hole can rip some of that matter off of the star and form a big disk that will kind of just eat the star slowly.
Just spiraling.
Yeah.
Okay.
So,
Kyle,
let's go to the vid. I will put the earbuds in for this one, just for the groovy music. There's nothing really
just music
to listen to other than that. But give me the go ahead to hit the play button, my man.
We are good. Kind of like the music. Like you said, 1.8 billion light years away.
So far away.
The star wandered too close to the black hole.
So this is what we're talking about, right? So this.
Yeah, like exactly. It
forms
makes that
disc.
trail, and then it makes the disc around it.
Right. Yep. And this would be the X-ray source.
Yeah, and then the X-rays come out. Like we were saying, very powerful gravitational forces.
Look at Kyle boogie into the music back there. That's what's up.
All right.
Cool. Thank you to Chandra X-Ray Observatory's YouTube channel for that video. Yeah, so that's cool. We've never seen anything like this.
Yeah.
This is another interesting thing in the universe.
Yeah, another data point of just another experience that we've observed as an astronomer, basically.
Yeah, unique. Very unique. So, one thing I didn't put in the write-up that they were saying is they don't expect the X-ray brightness to drop off anytime soon, either. They think it'll be another few years at least.
Another ongoing.
Yeah.
Okay.
So we'll see. I'm sure follow-up studies will be conducted.
It's always cool seeing stories about black holes because it's things always progress pretty quickly and we learn a lot.
Mm-hmm.
And it's amazing to think like what might we know about black holes in like 20 years or something. Like who knows? Black holes are a crazy thing.
Dude, they're crazy. Black holes, I love black holes.
There's got to be all kinds of secrets, right, about the universe that we could learn eventually.
My heart lies with planetary science, but black holes are just fascinating, man. They're so cool. Moving on?
Yes.
Number 3. Some biology time.
Yes. Good old biology.
Scientists have identified 2 genes within the Wolbachia bacteria that can sterilize mosquitoes during sexual reproduction. The mechanism by which the sterilization occurs is called cytoplasmic incompatibility.
So it's basically making it just not able to reproduce.
Right. If a male mosquito that is infected with Wolbachia bacteria mates with an uninfected female, the male sperm, which has been modified with a deubiquitinating enzyme called SIDB, will kill the female's eggs after fertilization, right? So the male and female get busy. The male is infected
with the bacteria,
and the infection causes this enzyme to induce cytoplasmic incompatibility. Right? Mm-hmm. So it kills the eggs upon reaching them. However, quote, the mechanism of cytoplasmic incompatibility is frequently modeled as a modification rescue or toxin antidote system in which sperm undergo a Wolbachia-mediated modification event that can be conditionally rescued in the egg by a Wolbachia-encoded factor, end quote. In other words, if a male infected with Wolbachia bacteria mates with an infected female, the female's eggs will rescue the sperm by releasing a counterpart protein, SID-A, and the reproduction system continues normally.
So if they're both infected, then things just happen normally?
Yeah, so the modification's still there, right? And the sperm reaches the eggs, but now the egg knows that the sperm is infected, and it saves it, right?
And it's we still need to make this happen.
Yeah.
Okay.
Pretty interesting. By identifying the genes responsible for Wolbachia bacteria's capability to induce cytoplasmic incompatibility, biologists suggest new techniques in mosquito population control that can help stop the spread of disease such as Zika and dengue, which is like yellow fever.
Gotcha.
The first technique involves inserting the incompatibility genes directly into uninfected males by means of genetic engineering. Right? So we know
we go into the male now that we know those genes, and we can just
put it right into their DNA, their genetic sequence.
So then they can't reproduce.
Exactly. The second technique involves inserting extra incompatibility genes into Wolbachia bacteria to already infected male mosquitoes to ensure cytoplasmic incompatibility takes place. Right? So it's just an additive effect. You put more of this gene into the bacteria, and it just makes it so that it will happen more efficiently. Right? It will just increase the odds that it will happen. Since the long-term effects of Wolbachia bacteria have not yet been studied, the first technique would likely be preferred. However, in areas such as the Florida Keys, where Aedes aegypti mosquitoes are intrusive but commonly found, residents are speaking out against releasing genetically modified males for population control. Right? So
these people are actually against this.
Right. They don't want to put the gene in the male mosquito.
To help kill all these offspring.
Correct.
Which could potentially be Zika and other dangerous things.
Correct.
And their worry is what?
They are nervous that they don't like the idea of being
sending like a genetically modified organism out there.
They don't want to be the test subjects of this.
They're like, oh, what if something bad happens?
Right.
Yeah.
And B, it's kind of a ritzy area, and they don't want more mosquitoes. Because you have to release more mosquitoes with this gene in order to crash the population.
Yeah, so you got to send these infected guys out to infect the whole population.
Right. And they're already like, there's way too many mosquitoes down here.
More.
We don't want more mosquitoes.
But in theory, if it works, then you're going to be getting rid of all of them.
Exactly. As reported in an article by Alexandra Sifferlin of Time magazine back in November 2016, the vote was split between residents of Key Haven and the greater Monroe County of Florida on whether or not the biotech company Oxitec should be allowed to release their similarly genetically modified male mosquitoes into the wild that carry a gene to kill mosquito offspring before reaching adulthood. Right? So this is a different technique that was developed last year by this company, Oxitec, and the residents were so against letting Oxitec do this, it came down to a vote.
Yeah.
Right? Concerns about the effects those genetically modified mosquitoes might have on the environment or human health caused voters in Key Haven to stand against Oxitec. However, with the split vote, the decision fell upon the Florida Keys Mosquito Control Board, who opted in favor of Oxitec. Right? So
there was a split vote, came down to the Mosquito Control Board. I never even knew that thing could exist. And then they called in favor of Oxitec,
right,
the company who was going to put these mosquitoes out there to help kill the population.
Correct. Oxitec reports that after a thorough investigation by the FDA, there was found to be, quote, no significant impact on human health, animal health, or the environment based on an environmental assessment of Oxitec's self-limiting OX513A mosquito, end quote. Right, so the FDA looked into it. They were like, this is okay. This is a good thing. People still don't want to hear it. Finally, in related news, the CDC's Morbidity and Mortality Weekly Report, which is my favorite name for a report ever, right, for March 3rd, 2017. For March 3rd, 2017, states that, quote, after the introduction of Zika virus to the United States, the proportion of infants and fetuses with birth defects born to mothers with laboratory evidence of possible Zika infection reported by the U.S. Zika Pregnancy Registry during January 15th to September 22nd, 2016 was approximately 20 times higher than the prevalence of potentially Zika-related birth defects among pregnancies during the pre-Zika years, end quote. So what they're saying is there are birth defects that exist, and up until Zika was found in the United States, there was a certain number of babies born with these birth defects.
And since the initiation of Zika being introduced to the system, there's been a 20 times increase
in the likelihood
of getting those.
Correct.
Nancy from the chat says that better than chemical spray for mosquito control.
So I agree.
I would agree with that as well.
Yeah. Chemical spray and the other kind of tactic they use is they'll spray oil. Just oil all over the wetlands.
That's crazy.
Yeah,
that's pure
craziness. That's what they've done in places like Panama and Central America to deal with overpopulation of mosquitoes.
So this is an FDA-approved way of controlling the population without putting crazy stuff into the environment.
Correct.
Seems like it might be a pretty good thing to look into.
Yep.
But I mean, I get people's fears and concerns, but I don't know. I mean, everybody's scared of everything, but
Sure. I mean, I'm more scared of Zika.
That's true.
Right?
I mean, I would be. I don't know. When you see pictures of the babies and the heads, it leaves a lasting impact on you, and that's kind of terrifying.
Yeah. Just to bring everybody up to speed on what Zika does, these birth defects include brain abnormalities or microcephaly, neural tube defects, and other early brain malformations, eye abnormalities, and other consequences of central nervous system dysfunction. Image credit in this one goes to James Gaffney for the mosquito pick. Yeah, I mean, exactly.
Andrew Lindner says that Zika is nasty.
Yeah,
it is.
Zika is a scary thing. So if we can... The other thing is that the mosquito, this particular breed of mosquito, is intrusive to the Florida Keys.
Yeah, it's not just a good natural part of their ecosystem.
No.
It's an intrusive species,
right,
which people aren't realizing.
So
because a lot of people would say, you get rid of this one population, it can collapse the ecosystem, whatever. But this is the intrusive species,
right,
already.
So we should crash.
We should already be counteracting against it, and it also fights these other things. So I would agree with that.
So
any other points on this one?
This was I chose this story A, because I just thought it was interesting, and B, because I'm going to the Florida Keys this summer for a wedding, and this is a concern of mine. I'm keeping up with this story because I don't want to expose myself to
any of this
stuff, whether it be Zika if it's still not under control, or if they go with the Wolbachia bacteria method, right? If they have widespread Wolbachia bacteria, that might be an issue. We don't know what that's going to do. It's crazy down there right now.
Yes.
So, but the wedding should be fun.
Yeah, still have a good time.
All right. Moving on. Number 4.
Let's keep going.
Elephants, Tom.
Nice. Good change of subject.
Good change of pace.
You can't not like elephants.
Wild African elephants now hold the record for mammals with the shortest amount of time spent sleeping, according to a new study by Nadine Gravette and colleagues. The researchers implanted a Philips Respironics ActiWatch Spectrum device, think a Fitbit, into the trunks of 2 female matriarch elephants for a duration of 35 days.
It's pretty cool. You can kind of put a Fitbit on an elephant.
Yeah, I love
observe its sleep patterns. This is cool.
This is like a whole new branch of science, right? This Fitbit tracking.
The technology
is really cool. An elephant's trunk is essential for interacting with their surroundings, so if the monitoring device remained inactive for over 5 minutes, the elephant was assumed to be sleeping.
Yeah, so if you ever look at an elephant, it's always moving its trunk around while it's awake. I don't know, unless most of your elephant interaction is from that show Wild Boys with Chris Pontius and Steve-O, but yeah, that's the way elephants work. When they're awake, they're doing stuff with their trunk.
Exactly.
So when they're not, they're sleeping.
Yeah. The results from the study showed that, quote, total daily sleep time in matriarch 1 averaged 2.3 hours, while for matriarch 2, total daily sleep time averaged 1.8 hours. If the data for both elephants is combined, the average TST is 2.0 hours. Despite this, during the recording period, there were 4 days in which the elephants recorded did not sleep at all.
So their average is 2 hours, and for 4 days they didn't sleep at all.
Right. Or they were at least inactive for less than 10 minutes at a time.
So they never got more than a 10-minute sleep. This is rough life.
Yeah. So this slightly increases these average times and slightly reduces the standard deviation. Thus, when these days of minimal to no sleep are eliminated from the analysis, TST in matriarch 1 averaged 2.5 hours. For matriarch 2, TST averaged 1.9 hours, while for both elephants combined, the average TST was 2.2 hours, end quote. That is so little sleep, Tom. So little sleep. The 4-day marathon stretch without sleep may indicate a period where the elephants felt threatened by a predator, poachers, or even a male elephant nearby, so removing the anomaly can help better assume an average. Important to note is that the elephants did not sleep just once per day for the durations listed, but rather would take 3 to 4 shorter quote-unquote naps alongside 1 longer sleep episode per day.
So I was actually, when I was thinking about that exact sentence, how they take a few shorter naps and they got to be awake almost all the time, it's different to think about an animal who's in the wild that has all the stresses of the environment, predators and things on them. Whereas, we have this nice system set up where people eat breakfast and they go to work and then they have their bed. Like, we can consistently know we'll always go to bed at 10 o'clock then, or whenever. We know that we'll have time to sleep. Whereas in the wild, it doesn't really work out like that.
No.
So it kind of just developed this way. Like, the elephants don't have the luxury of sleeping all night.
No.
They wouldn't survive that way.
They're constantly on the move. They're a big target. So they're constantly being hunted by things that are looking for a meal. And sleep, is just not in the cards for them, really. They're herding, right? They're herd animals. So
they all got to keep moving on together.
Yeah. Gyroscopic information was correlated with the sleep patterns in order to determine whether the elephants were sleeping standing up or lying down in a recumbent position. Quote from Matriarch 1, the total amount of time spent in recumbent sleep over the 35-day recording period was 11 hours, 58.8 minutes. While Matriarch 2 spent 7 hours, 33 minutes in recumbent sleep, end quote. And, quote, each elephant only exhibited recumbent sleep on 10 of the 35 days of recording, end quote. So they only, lay down to sleep once in a blue moon, right?
Usually they're just standing up, taking these power naps and...
Crazy. While the sample size is very small, the researchers hint at future experiments looking at whether or not there's a relationship between mammal size and a total daily sleep budget. Is it possible to prove that larger body mass mammals require more time spent being awake in search of food to support themselves? What do you think?
Yeah, so this is an interesting one. So their main theory is that they're really big. They require a lot of consumption, so they always got to be on the move to have a reliable next meal.
Right.
Always.
Right. Yeah.
Makes sense.
They only tested this out with 2 elephants, so it's hard to draw that conclusion, but...
So Kayla wrote in the chat, said she was thinking about, do they need to do further experimenting, like saying, do they need to rerun the experiment, like how reliable is this data? So I would say, it's always good to do more and more testing and to be reliable, but it's kind of like a Fitbit on the elephants, and they followed them for a month, they said, right? Or 35 days?
35 days, yeah.
So it was only these 2 elephants, but I think from what they know about the elephants' lifestyle and herding and their patterns, I think that's kind of how they drew their conclusion as to the data combined with the observational stuff of how we see how elephants move, as opposed to just the data that they got from how elephants sleep.
True. Another thing to keep in mind here, I don't know for sure. I couldn't find it explicitly in the published paper. I'm sure it was there, but it's a long paper. I believe, though, that these 2 matriarch elephants are part of the same herd. So could it be different
for another
herd
that lives in a different area that might have less predators? Possibly. Who knows?
Possibly. Maybe they have a better route that they migrate across Africa with. I don't know.
But yeah, I think it's cool to look at, because just learning more about sleep in general, because we do it so much as a species and a lot of animals do it. I just think the more you can learn about sleep and how animals utilize it, it's a pretty cool topic for research.
Yeah, I agree. And like I said, I like this Fitbit style.
Where you can just pop something on an animal and track it.
Cool idea.
Right.
Image credit for the African elephant image goes to Martin Harvey of the WWF. That's the World Wildlife Foundation, Tom, not the rest.
Do you remember when that was a thing, when they were like, the WWF's got to change?
Yeah.
I was like, wait, what do you mean?
Yeah.
I was like, this is the WWF. So they just changed it to the WWE.
Yeah.
They were like, whatever. John Cena.
WWF versus NWO. Oh, man, I was all about that when I was younger.
Carrie had a comment in chat saying that the heart rate of a mammal and its lifespan is connected. So I think I've read something like that, where usually if you have a longer lifespan, you have a slower heartbeat.
Interesting.
A general correlation. But I'm not exactly sure how that all works out.
Wow. So Kyle, man, clock's ticking, bro, with all that coffee you drink.
Oh boy.
Oh boy.
Heart's always going crazy. All right.
Number 5.
Elephants are cool. All right, moving on.
This is
on a brighter note. No,
this is not a brighter note. This is more of a PSA.
Yeah.
Colorectal cancer cases in the United States has been increasing in people under the age of 50, a study by the American Cancer Society reports. According to statistics gathered from the National Cancer Institute's Surveillance, Epidemiology, and End Results program, the Centers for Disease Control and Prevention's National Program of Cancer Registries, and the CDC's National Center for Health Statistics, colorectal cancer incidence and death rates are decreasing overall, but have increased in young and middle-aged adults in recent years. Quote,
so completely overall, it's actually on the downtrend.
Right.
But for people under 50, it's actually on the up.
Correct.
Okay, so it's actually a pretty relevant problem for people under 50 now.
Yes. Quote, between 2000 and 2013, incidence rates in adults aged greater than or equal to 50 years declined by 32%. However, among adults aged less than 50 years, colorectal cancer incidence rates increased by 22%, end quote. So that's almost a quarter, dude. 22%. Yeah. That's a lot.
You know what I always like to say? When it comes down to, at the end of the day, people are just, they're plumbing. They're just a bunch of tubes. It comes in and then it comes out. You got to keep your tubes working.
Yeah, it's true. Likewise, for mortality rates, quote, death rates decreased by 34% among individuals aged greater than or equal to 50 years during 2000 to 2014, but increased by 13% in those aged less than 50 years, end quote. The authors of the study suggest that screenings for colorectal cancer should begin by at least age 50, being the average risk, or ideally earlier. Maintaining a healthy body weight, cutting down on red meat consumption, not drinking excessive alcohol, and quitting smoking can all significantly reduce the risk of colorectal cancer. Image credit goes to Blausen Medical Communications Incorporated for their graphic that we used. And I tried to find the least graphic
the least graphic
for this one to save your eyes, guys.
Because we are talking about colons here.
Yeah. So no, this is scary stuff though, because we're always fighting against cancer, and to see
you have to be preventative.
Mm-hmm. Yeah. To see it on the upswing at all is scary stuff. I have kind of a little funny story just to make light of this whole situation, even though this is a very serious topic. So, yeah. Oh, I'm gonna bring them up. So,
right, so what do we got here?
Last week, I'm doing my business.
Okay.
All right, if you will.
I think I know what you're saying.
Yeah. And I realize bright red.
Oh.
Yeah.
Danger.
Danger, right? So
happening?
I'm like, immediately I'm thinking, did I eat beets? I consume a lot of beets in my diet, Tom.
So maybe that's a
possibility. And that beets can turn your stool red.
Yeah.
Did not have any beets though lately. So now I'm getting nervous.
Did you have anything else?
Here's the thing. I did. I was worried about it. Right. I was like, let me monitor the situation. If it happens again, I'll have to go get checked out at a doctor's office or something. It doesn't happen again. I'm talking to Kyle last night. I'm pondering around on the internet though.
Oh, I saw your Facebook post.
Dude.
I saw it.
Of course, I have to try all the different Oreo flavors that come out.
They're peep-filled Oreos.
Peep-flavored Oreos are turning people's poop pink.
Kayla, John's girlfriend in the chat, says gross. That's gross. But so beware of the peep Oreos.
Yeah, quick disclaimer. If you're eating Peep Oreos, if you're a weird, these are horrible, by the way.
Yeah, just get the double stuffed.
I know.
We don't need the Peeps.
You gotta try it. They're horrible. They turn your poop pink. You don't have colorectal cancer.
It's Oreo Day.
Today is Oreo Day.
Today's like National Oreo Day?
Today is Oreo Day. You want one?
No.
I
think we're all good. Alright, so that's just another
PSA.
Yeah.
A PSA on top of a PSA. If you will.
Pink poos. I told you to stop buying those weird Oreos.
I'm sorry, I can't help it. They only make one batch.
All right.
Sorry.
Moving on.
Number 6. The temperature of Earth's mantle, the interior layer between the crust and the core that makes up about 84% of Earth's total volume, is thought to be about 60 degrees Celsius hotter than previous estimates, according to a study by Emily Sarafine and colleagues. Due to the fact that temperature increases with depth in the Earth's interior, there exists a point at which the solid rocky mantle reaches a melting point and becomes a viscous liquid known as a solidus.
So a solidus is actually just a really thick liquid?
That's
extremely thick.
That's what I got from the paper. I don't know for sure.
Okay.
The only Solidus that I'm familiar with is Solidus Snake from Metal Gear Solid 2.
This is a different
This
one.
is a different one. For many years, geologists have been experimentally recreating the conditions of Earth's mantle by synthesizing mantle rock from various combinations of minerals and exposing them to extremely high pressures to see at what temperature the rock melts.
So in the laboratory, they literally just take rocks of known compositions and they actually put them under pressure and temperature that they'd be in inside the Earth. They actually do these experiments.
Correct. They just squeeze the heck out of them.
Yeah, they squeeze the heck out of them and heat them up, and then they see what happens to them.
Yeah, and they try to figure out where the melting point is, right? At what temperature.
What temperature, do you get that viscous liquid?
So water plays an important role in these experiments. Trace amounts of water exist in mantle rocks in the form of peridotite, which can lower the melting point.
So when you have water in it, it makes it harder to melt it. Correctly? Is that what we just said, or is it the opposite?
Opposite, right? So water is going to lower the melting temperature.
And make it easier to melt.
Correct.
Just want to get that clear.
Yeah. No, this was a tricky one for me to write, so let's definitely work through this one together. When conducting their experiments, scientists have not been able to directly measure the water content due to the small grain sizes of the minerals that grow in the synthetic peridotite at mantle pressures and temperatures.
So these rocks that they made, they don't know exactly how much water's in them.
Correct. So from my understanding, you have the collection of minerals that they put together to form some unknown rock composition. The rock forms as you increase the temperature and pressure.
It all comes together.
These minerals grow amidst
They crystallize.
They crystallize. Yeah. But once you've done this, the minerals that you get in peridotite explicitly is olivine and pyroxene, but these minerals that contain the water are so small you can't measure them.
You can't even see it.
Instruments. You can't do it. So that it's all been guesswork, right? Instead, they would typically try to completely dry out their peridotite samples and mathematically account for the water content afterwards.
Yeah, so they tried to get as dry as I could, and then whatever discrepancies, kind of just throw it in the math at the end.
Correct. But since there's water in our atmosphere, the minerals absorb some of the water, and the experiments have always had some unknown amount. Right? So
there's always just been that unknown factor
there. Right. The study conducted by Serafine et al. Instead makes use of a mineral called olivine to provide a known amount of water to the synthesized peridotite. Pure olivine grain sizes are large enough to be measured, and olivine is found naturally within peridotite, making it a perfect candidate. Right. So now they're taking, instead of just drying all these minerals out and doing the experiment and then figuring it out afterwards, they're actually putting pure olivine grains in with the rest of the composition of the rock, because they can account for the amount of water, right? The experimental results showed that, quote, the H2O undersaturated peridotite solidus is hotter than previously thought. Reconciling geophysical observations of the melting regime beneath the East Pacific rise with our experimental results requires that existing estimates for the oceanic upper mantle potential temperature be adjusted upward by about 60 degrees Celsius, end quote. This hotter temperature means the solidus could be less viscous in nature and could lead to a better understanding of observed motions of plate tectonics. Image credit goes to discovermagazine.com for the Earth layers here, Tom.
So before we get into it, Carrie Cleta in the chat said Stony Brook University MPI does this on a regular basis at BNL at the NSLS, which is the National Synchrotron Light Source.
Yeah, awesome. I knew Stony Brook was involved with these type of experiments. I did not know that they did that in conjunction with Brookhaven National Lab.
It's pretty cool.
Which I should know that.
Yeah, because you actually still work there.
Yeah.
So as we break it down, just real quick before we move on, it's kind of just like a constraint of the geophysical models now, that this allows them to have a better understanding of the mantle, the interior of the Earth. And as they get these melting points, these temperature pressures a lot more solidified, not to use that word because things are actually drying up, but as they get these constraints better understood, their model becomes all that more powerful, right? And all their understanding of the way the interior of the Earth works is just more understood.
Correct.
Because of these parameters that they now understand.
Right.
James asks, who's the author on this paper?
The author is Emily Sarafine.
Emily Sarafine?
Sarafin. And I'll include the links to
we'll put the links to the papers
in the YouTube
descriptions.
Yeah,
okay,
exactly. So you can take a look at that.
All right.
Afterwards, I figured James would be interested in this one, so this one's for you, James.
This one goes out to you.
Number 7.
How does this research aid in finding the trail to the journey to the center of the earth?
Oh,
isn't it that movie with The Rock?
Wait, Journey to the Center? No, that's with the... Shoot. I saw this movie in 3D. Oh my goodness.
No,
wow.
It's is it the guy from The Mummy? That guy?
Yes.
Whatever his name. What's his name?
Oh man.
How do I not know his name? Oh, James is talking about Core, that movie.
You were talking about Core.
James
before.
also just mentioned in the chat. The movie The Core is that really bad movie where they have that giant thing and they drill into the earth and they have this crazy representation of what the inside of the earth looks like. That one's bad.
Journey to the Center of the Earth, also not great, but based off of a book that was a classic back in the day. So
Brendan Fraser.
Thank you.
James knows his Brendan Fraser movies.
Thank you. Yes, Brendan Fraser.
All right.
So, number 7. Last week, NASA hosted the Planetary Science Vision 2050 workshop. That's a cool name. Event at their Washington, D.C. headquarters. Among the various talks and presentations, Planetary Science Director Jim Green discussed an intriguing idea to deploy a magnetic dipole shield in Mars's L1 Lagrangian point to act as an artificial magnetosphere. So let's unpack that.
This is a pretty cool one. So
Yeah.
first, what is a Lagrangian point?
First, Lagrangian point is a point between two orbiting bodies where the pull of gravity is equal, right? It cancels each other out. So the L1 Lagrangian point is between the Sun and Mars, right? Where the Sun has equal gravitational pull
as Mars does.
So
it's in between the two.
Right. So you can put things there. You can put satellites there.
Because that's a center of gravity, and they can actually be just in
that
that spot.
It won't move. Yeah.
So that's a Lagrangian point. A nice little convenient spot.
Yep.
And they want to put an artificial magnetosphere.
Right.
So they're basically saying, well, we're going to put a magnet out where it won't move in a nice little convenient gravitational spot.
Yeah. Big one.
A big one, though, yeah. Not a little one.
Yeah.
They even use the word inflatable in the article.
Yeah, which...
I don't know what that means. But you get the magnet there, and they're saying you have the magnet there. The solar wind that's coming in now will be deflected around the magnetosphere.
Yep.
So it will stop stripping away all the atmosphere that would be on Mars.
Yeah.
So they're saying allowing this protective layer to be there, you kind of could build a atmosphere on Mars this way.
Right. Kyle, do we have the graphic for that? I think we'll have that brought up in just a second. So, giant dipole magnet, solar wind coming in, gets deflected, right? This is what happens on the Earth. The Earth has its own
we have our
field, which is nice.
Field. So, that's what protects us.
So, instead of Mars having a magnetic field, we're going to put one a little bit in front of it, and it will follow Mars in its orbit around the Sun and basically block that solar wind at all times.
We can leave it. So it seems like an easier way of terraforming. Instead of having to transform the whole planet, let's just block that incoming stuff. Like James says, terraforming. This is like a kind of a neat idea.
Yeah, this is a pretty cool one.
I like this one.
So let's keep going.
At first
here.
I was skeptical, but yeah, all right, let's keep going.
The Earth's natural magnetosphere is what protects our atmosphere from being bombarded by energetic particles spit out by the Sun, known as the solar wind. It is believed that ancient Mars once generated its own robust magnetic field, but somehow lost the internal mechanism driving it about 3 billion years ago, and the Sun's solar wind has stripped the Martian atmosphere into space ever since. Without a thick atmosphere, Mars grew cold and dry, and lost the ability to sustain liquid water at its surface. So even though we have found very, very small trace amounts of liquid water now flowing on the surface of Mars, it's not like it can't sustain it, right? Artificially creating a magnetosphere to protect Mars from the solar wind could restore its atmosphere, according to the talk. Quote, "It has been determined that an average change in the temperature of Mars of about 4 degrees Celsius will provide enough temperature to melt the CO2 veneer over the northern polar cap. The resulting enhancement in the atmosphere of this CO2, a greenhouse gas, will begin the process of melting the water that is trapped in the northern polar cap of Mars. It has been estimated that nearly 1/7 of the ancient ocean of Mars is trapped in the frozen polar cap. Mars may once again become a more Earth-like habitable environment, end quote.
That's kind of that's tempting, right?
That's very tempting.
Pretty cool.
They go on to say, quote, a greatly enhanced Martian atmosphere in both pressure and temperature that would be enough to allow significant surface liquid water would also have a number of benefits for science and human exploration in the 2040s and beyond. Much like Earth, an enhanced atmosphere would allow larger landed mass of equipment to the surface, shield against most cosmic and solar particle radiation, extend the ability for oxygen extraction, and provide quote-unquote open air greenhouses to exist for plant production, just to name a few. These new conditions on Mars would allow human explorers and researchers to study the planet in much greater detail and enable a truly profound understanding of the habitability of this planet. If this can be achieved in a lifetime, the colonization of Mars would not be far away, end quote. Image credit goes to NASA and Jim Green for that nice graphic.
I like this one.
I do too. This is cool. Terraforming Mars has been bouncing around. Elon Musk talks about it.
But there's never been any plausible idea.
No. People have referred to nuclear detonations at the poles to melt the ice caps. But then you get radiation in.
You don't want to. You don't want to blow up a nuke on a planet you're trying to start to live on.
No, that's a bad idea. This is an interesting one, though. This is a very clever idea. Would be, of course, difficult to
actually implement and get it to work.
Yeah. And like you said, we were reading it, they refer to the magnet as inflatable. I don't know what that even means.
I don't know.
But, they must be pretty confident about it if they're talking about it.
They're actually going to bring it up.
Yeah.
Because you don't want to get made fun of at a...
No, this is the director of the Planetary Science Division of NASA.
Yeah. He's not just like staying up at 3 a.m. drinking a Monster, like, I got to put something together here, He's actually thought about this.
Yeah. So I thought that was pretty cool.
And then to round off, just at the end.
Yes, sir. And Kyle, we can actually bring up that video because there's actually no sound to it here. So I'm going to do this. I'm going to snap my notes over here.
They could definitely grow more potatoes on Mars if they did this. For sure. Matt Damon would be excited. All right.
So the last one here. Speaking of the Martian atmosphere, the Curiosity rover captured some wonderful footage of dust devils on the surface between Sol 1597 and Sol 1613. A Sol, Tom, is a Martian day.
Just a Martian day, yeah.
It's equal to 24 hours, 39 minutes, and 35 seconds, so Mars rotates a little bit slower than the Earth does.
Slightly slower.
These whirlwinds occur more frequently in the summertime on Mars, whipping dust across the Gale crater where Curiosity has been exploring. Not the first time dust devils have been observed, but still cool. What happens is the more direct sunlight in summer heats the ground, prompting convective rising of the air. The dust gets picked up by the rising air more easily on Mars since the gravity on Mars is only about 1/3 of Earth's. Video credit goes to NASA JPL. So, I don't know, can we run that one back again just so that everybody gets a chance to see it? Is that possible?
While we talk about it, just leave it on in the background. Yeah, so kind of the same thing on Earth. As you heat the air, hot air is less dense and it rises. And in the same case, this hotter, less dense air as it rises begins to spin a little bit. And like you said, because there's less gravity, it actually doesn't take that much convection to get these small grain particles to make these dust devils going on.
Yeah.
And somewhere in the article, I know someone got confused on the YouTube comments. They say the actual mass of stuff that it's moving, but each individual particle is very light. Even though it all adds up to maybe something substantial, but every little particle is super light. So that's how these dust devil forms. The wind speeds aren't like super fast for these ones, I don't believe.
No, I think you're right. I think they're
kind of like small scale little events.
Yeah, I mean we see, like
but
you
there
said,
are dust storms. But
yeah, we see these on Earth though. These little cyclones.
These little. Yeah.
But here they look a little bit more dramatic because
those little dust particles are so light on Mars and they just get swept up.
Yeah, pretty cool. So Mars has a nice
a
nice little thing going here.
Pretty cool that you can just watch a video of a little dust storm on Mars though.
Yeah,
pretty wild.
That is pretty wild. We were watching Planet Earth, obviously, on Saturday, and I told Kayla, I can't wait. I hope that the first crew that goes to Mars is the team, the Planet Earth team, and they make Planet Mars. That would be so. It's all just geologists that are like telling you all the stuff that's going on. Oh man, that'd be so sweet. So with that, that's all the news.
Wrapping it up.
We'll wrap it up. We'll hang out with you guys in the chat for a few minutes if there's any questions, comments,
about any stories, about
jokes. If you want to make fun of Kyle, that's fun. No, I'm just kidding.
But yeah, thanks for tuning in.
Of course. Thank you guys.
We try to bring you a bunch of different topics each week. Try and keep them varying. All subjects.
Yeah.
Find interesting stuff that we like to talk about.
Hell yeah. Sweet.
So thanks for stopping in, guys. Hope you enjoyed yourself.
How'd we do this week, Kyle? Solid? Yeah.
Nancy Cleta says, I always make fun of Kyle.
Oh.
Roasted.
Man. Yikes.
Roasted.
Cool. What do you got going on this week, dude? Anything crazy happen?
No, not really.
That's good.
Nothing too crazy.
I have to bring Mush to the vet.
He's sick.
He's not sick. He's got this itch underneath his chin. He keeps scratching it. It's getting all raw now.
Oh.
So I hope it's not an infection, but I think it might be an infection.
So I just realized in the chat, Andrew Lynn there, I'm pretty sure that's Andy the Bomb.
Oh, that is Andy the Bomb.
Yeah, right?
Definitely.
I knew it was at first, but now I'm just like bringing it to light.
Yeah. Shout out to you, Andy the Bomb.
And HMAX is here as well.
Right on, dude.
Right?
That's awesome. Thank you guys for joining us.
Yeah. Awesome.
So after this, we'll probably all just hop on Overwatch
together. I might catch you online.
Right on.
Cool.
All right. Well, what do you say? Wrap this pancake?
Yeah, we'll wrap it up.
All right. Thank you guys again.
I don't think there was too many loose ends on this one. I think our stories are pretty well covered.
Yeah, the analysis I think was pretty straightforward for this week.
Sweet.
So, thank you guys for joining us, and we will see you again next week.
Yeah, catch us next week.